Alright, calcularians, today we're going to take a look at the chain rule and investigate what it is and how to use it algebraically. If you haven't watched the episode with me describing the chain rule in terms of boxes and functions inside of functions, it might be helpful to take a minute or two to go through that video first. So, either way, we are here today and we've got a function 5x minus 3 squared. Now, let's first go to a world where the chain rule does not exist. Chain rule, no. And we're okay in this world because we can say f of x is really just the function 25x squared minus 30x plus 9. Now, what I did there is I foiled that out really fast in my head.
Holy smokes!
The good news is if you can't do that super fast, you're totally fine. Just kind of follow along for now. So, rewriting f of x is fine, and I can say, well, f prime of x, I'm going to use my shortcut rule. 2 times 25 is 50x minus 30x. The derivative is 30. The 9 is a constant. The derivative of constant is 0. So if f of x is 25x squared minus 30x plus 9, then the derivative is 50x minus 30. Yeah, thanks. Well, if I want to look at it where the chain rule is in effect, the chain rule, if you saw the other video, we apply the chain rule when we have a function inside of a function. So my inside function is 5x minus 3. My outside function is something squared. So if you can recognize this, using the chain rule to take the derivative, f prime of x, I take the derivative of the outside function, so that's going to be 2x. But in this case, my x is this thing. So if I come up here, the 2 is going to come out front. So I get 2 times 5x minus 3, raise it to the 2 minus 1 power. And then as you hopefully have seen in the other video, with the chain rule, you take the derivative of the outside times the derivative of the inside. My inside function is a 5x minus 3, so I'm going to multiply by 5, which is the derivative of 5x minus 3. When I clean all this up, I'm going to do my 2 times my 5. Those are just two numbers that I'm multiplying together. That's 10. Then I have 5x minus 3 to the 2 minus 1 power, which is just the first power. Keep simplifying, I get f prime of x is 50x minus 30, which is what we saw in the world without chain rule. So here our two worlds are giving us the same derivative. So the chain rule is no joke. We can actually do it. So in the last 60 seconds, what I want to talk about, why do we care? Because if I have a function that I can just FOIL out and I've got super mad foiling skills, why not just do it this way? Well, the chain rule, as I just showed you, gives us the same exact answer. We're just doing a little bit of algebra. Is really nice if I have g of x is 5x minus 3 to the 19th power. Now, if we go into that world without the chain rule, I have to take 5x minus 3 times 5x minus 3 times 5x minus 3. Keep multiplying by 5x minus 3 19 times. Foil all that out. And then I can take the derivative using our old shortcut. But I don't want to live in a world where the chain rule doesn't exist, because I love the chain rule. And if I apply the chain rule here, I take the derivative of the outside function, which is something, this inside function, to the 19th power. So my chain rule is going to tell me it's 19 times 5x minus 3 to the 18th power. So I just took the derivative of the outside, 19 times my thing to the 18th power, and I multiply by the derivative of what's inside, times 5. So g prime of x, if I want to clean it up, I do my 19 times 5, let's see, that's 5, 95, times 5x minus 3 to the 18th power. Loving the chain rule. Helps me to take derivatives of those huge functions.
Holy smokes!
All right, good work. Keep practicing. We'll see you soon.